to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello, I am Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is what I am calling... I forget what I'm calling this. It's a term that I made up. What did I call it? Transparent distributed architecture for the Automixer, whatever. We are doing real-time audio effects using the JSFX language in REAPER. And we are also building a library along the way, but what we are doing today has little to do with the library, has a lot more to do with the Automixer. An Automixer is an effect that helps you mix microphones that may be open in the same room and reduce cross talk and bleed between the microphones. So if there are multiple people in a room, in a kind of an interview setting, then when one person speaks, their voice is picked up by their microphone, but also by every other microphone in the room, and the Automixer will decrease the volume of other microphones because it notices that the volume of these other microphones is a bit lower, so it decreases the volume even further, reducing crosstalk. For this plugin to work, it needs to have access to the audio coming from multiple microphones to compute their different gains and to set their different volumes. Or I guess to compute the loudness of the signal coming in and decide what gain to allocate to them. And right now, the way that we are implementing this is following the implementation of the original Automixer for REAPER. There are two versions already, one by Corey Skogin and one that I made. And the version that I made is using some REAPER specific features that I'm trying to avoid because I also want to translate this effect into C++ to use it in any other DAW. And the approach used by Corey here seems to hold better in that context where you would be using this in other DAWs. It's still JSFX, so it's mostly a REAPER thing for now, but when I translate it to C++, it will be cross-DAW. The way that we are implementing this and the way that Corey implemented this is you have many instances of the Automixer. So let's have two tracks. Find our Automixer and drop the Automixer on the two tracks. This is the regular setup that I'm doing for testing the Automixer. At some point down the line, we will actually have multiple microphones open in a room and have some kind of interview recording. But for now, I'm dropping a tone generator in one track. The tone generator will be around -20, which is similar to the level of my microphone. And then I turn on the microphone. And it seems like the Automixer is not really working at this point. And that's exactly what we are going to talk about today. The problem is that the different plugins need to talk to one another, because they need to communicate what is the current volume of the signal coming through to decide how to attenuate the other microphones. And the way that they are doing this is, and this is how Corey implemented this in his Automixer as well, is when I hit play, the plugins are going to register themselves into this global namespace that every plugin sees. And then the different plugins will be aware of one another and can collaborate, can decide what gain to allocate to each microphone. So as I speak, I'm going to hit play and you'll see the playhead moving. And you will see these meters bouncing because the Automixer is going to kick in. So watch out for this. See, now it is bouncing down. And when I speak, the sine wave is bouncing down to make space for my voice. And then it comes back. The issue that we are trying to solve is this, and again, note that when I stopped playback, the meter is stopped, which means it's the Automixer is no longer active. What we are going to do today is alleviate this need for the playhead to be moving, because for the most part, I think that people use Automixers when editing in post-production, so this limitation of having to have the playhead moving is okay. But I do know of some people who use my Automixer for live situations, and it probably is okay to ask them to keep the playhead moving, but it is annoying. So I think I came up with a solution for not needing to hit play. And I think it's a robust and elegant solution, and that's what we are going to implement today. Hey, Bo is here. Hello, Bo. It's great to see you here. I hope you're feeling better because yesterday you said that or 2 days ago, you said that you were not feeling too well. I checked the C stream. Fell asleep. Okay. I hope that you're feeling better now and that sleeping was recovery time for you. But yeah, the C stream. C is actually a thing. I think. It is a thing. I think. Difficult to say. Because I think that there is a kind of a language that is a subset of C or a subset of C++ that is meant for like writing papers about programming language theory. But I forget. I know for sure that there is something called core Java along the same lines. Anyway. Oh, I have to say, for all the bad things that happen when there are heat waves, at least for me, I quite enjoy it. I know that there are fires and people are distressed by the heat wave, but I'm in. I am in. All right, I'm happy that you're feeling a bit better, and I hope that you find today's session entertaining and perhaps even educational and instructive. Let's get down to the idea. First of all, why is this happening? Why do we have this issue? Why do Automixers stop working when the playhead isn't moving? That's because we have this need for the plugins to communicate, and the way that we are doing this is they are registering themselves into this global address space. And I need to have two pieces of data for the Automixer to work. First, I need to know how many instances there are of the Automixer on the whole project, because all the instances need to talk to one another and all instances need to make sense of how loud are the other guys so that I can attenuate myself. So I need a notion of how many plugins are there total, in this case 2. The second is I need to know the loudness of the tracks of the active microphones. And you should be able to add new Automixer instances and new tracks and remove Automixer instances and tracks and bypass the effects. You should be able to do all these things. You perhaps should be even able to automate some of the settings, like you should be able to write an automation lane that disables the plugin for part of your podcast, if that's what you want to do. So that's what we would like to have happen. But in reality, the way that we are doing this is we are registering the plugins. So when you hit play, the plugins will see that as an event and will say, oh, the person just hit play, so I'll go and register myself into the global namespace. And when the playhead stops, the plugin says, oh, okay, this is over. I'm going to take this event as an opportunity to unregister. And why do I want to do this? Well, because if you, for instance, you are the plugin and you're bypassed, you are done. No code is going to run anymore. There is no event that you can catch, no way that you can react to the event of the plugin has been bypassed. Your plugin just stops working altogether. So how can the plugins collaborate and say, oh, I have been bypassed, don't take me in account anymore, you other instances of the Automixer, don't take me in account anymore because I have been bypassed? Well, there is no way for you to communicate that, because when the plugin is bypassed, it stops on its tracks, it stops working altogether. There is no code that runs after that. So here is the idea. Instead of having play be the register event and stop be the unregister event, how about we get rid of the concept of registering and unregistering altogether? How is that going to work? Well, we are going to still use the global namespace as a means of communication between plugin instances. But what we are going to do is we are going to find a free spot in the global namespace. And I have a strategy for how to do this, and I will talk about it in a moment. Then we are going to store on this global namespace, not only like we are already doing, the RMS, the loudness of the signal coming in, we are still going to store that. But we are also, in addition to that, going to store the timestamp in which we have written that information to memory. Then other plugins, when they need to, other plugin instances, when they need to compute the loudness of the other guys, it will also look at the clock and it will say, oh, this is old. This information has been written here half a second ago. That's stale information. It probably means that the effect is bypassed or has been removed or whatever. And then in that case, we just ignore that information. We skip over it. But if the plugin is unbypassed, it will continue to write to that location, and then all the other instances will see, oh, there is a new guy there. I need to take that in account. That's the strategy, to store the RMS as we are already doing, but also store a timestamp and check the timestamp to see if the samples that have been stored are new enough, so to speak. Okay, back to regular summer, which I think is a mild summer, I suppose. In Sweden, I don't think you have too bad of summers there. The frequency response of your filter is most probably affected by the adjacent output and input. They have their own impedance and capacitance. What? I think you're talking about the Wednesday stream in which I was showing a circuit that was a simple low-pass filter, but the point was to show Room EQ Wizard as a way of measuring the frequency response of a filter. And that eliminates things like noise coming from the audio interface to the extent that it's possible, and the filters that exist in the audio interface itself. And I showed all that on Wednesday, but then Bo is reacting to that, I think. And the frequency response of my filter was not the frequency response that we calculated. We computed the frequency, the cutoff frequency that we expected to have from the filter using a calculator online. And you can also use a very simple formula. And then we measured, and we didn't get exactly the results that we expected. So Bo is saying that maybe that was because, and that was probably because the frequency response was affected by the adjacent output and input. And they have their own impedances, capacitance. Yeah, so I had to, in my little sketchy setup here, I had signal coming in and out of a breadboard, and the cables were next to one another. So perhaps they were affecting one another because of that. And if they have their own impedances, and that means resistance and capacitance, it means that they could be forming a filter in and of themselves. Now, I understand this, but I'm not sure I think that this is the case, because the cables were close enough in both measurements. When I measured the... I did two measurements. First, I did a measurement of just bypass, audio coming into the breadboard and going out of the breadboard, and that was it. No components in the middle. So I did a measurement of that, and the second measurement took the first measurement in account. The second measurement was of the filter, and that took the first measurement in account. So any impedances and capacitances of the wires and the inputs and outputs, and even the USB interface, those should have been taken in account in the first measurement and eliminated on the second. That is the whole point of how Room EQ Wizard works and why we calibrate it in the first place. So maybe I am misunderstanding something else that's happening, but I think that the first measurement should be taking in account the impedance of the USB interface, as well as the capacitance of multiple wires being next to one another, and even a breadboard can act as, I guess, an inductor of sorts, and get the cables and whatnot. Anyway, there is a video by Ben Eater talking about the inductance and capacitance of doing stuff on breadboards, because he does entire computers on breadboards. Anyway, let's get down to code. We are going to implement this notion of storing time along with RMS computation, and the notion of the different notion of registering and everything. And I think it's such a pervasive change to the plugin, and it is such a short plugin so far, and it makes sense to just reread the whole thing. So the sliders are not going to change. We are still going to have the RMS window length there. And all of this makes sense. And all of that makes sense. And then we get to this part. And this is where we are looking at the playhead to determine if we should be registering plugins or resetting. So this is what happens when we register the plugins, when we hit play. And this is when we hit stop, all the plugins reset and they stop working. So let's revisit this section. Well, we still need to have this notion of registering. We still need to have this notion of finding a place in the global memory that is available for us to write to. The difference is that there will not be a notion of unregistering anymore. We will find a place in memory for us, we will claim that place in memory, and we will be sitting in that place in memory forever. Which means that we don't need to do this on the block section, because we don't need to be re-registering over and over, right? We can do this in the init section. So in the init section, let's find a place for us. Well, it's kind of bad to do this in the init section as it stands, because as it stands, it is going to be rerun every time the playhead starts. And we want to do this only once, for real, only once. So I think we want to have this so that the init section runs only once. But I'm going to leave this commented out because I want to observe the problem really happening before I fix the problem. Anyway, how are we going to find an address that is available to us? This is going to be a global variable for the plugin, but it will be a variable that is for this instance. It will not be a variable that is shared by everyone. And I think we already have this notion. It is I guess what I'm calling the track current. Whatever. I guess I would just call it track. I'll continue to call it track current. And that's also a thing that existed before, yes. Oh, it is actually just this. I can just take the code that registers the plugin and paste it here. Great, I don't have to rewrite it, though it is just 2 lines and I already have rewritten one of the 2. But anyway, here are the 2 lines, and this is what we do to register the plugin. Note that, yes, there may be a race condition here if 2 plugins are running this section exactly at the same time and both run this line and then both run this line, they will get the same ID. Whatever, let's not worry about this case. So now we are registering the plugin. Let's see this track current change over time as we load the plugin and hit play, hit play, hit play. It should be changing. So here is our track current, and as I hit play, it keeps changing. Oh, and what's worse, it is being reset, but that's just because we renamed, we reused this name, and then when I hit stop, the plugin is unregistering. So I guess let's take all of this out for the moment. This is what was registering and unregistering on playback, and keep just this code that is doing the new strategy. So yeah, as I hit play, it registers itself again, and when I hit stop, for whatever reason, it registers itself yet again, and then again, and then again. We don't want that. Let's enable this, which is a special thing in JSFX. If you set this variable to 1, it means that you only want to run this code once. Okay, so now the track current is no longer changing as I hit play, but what's crucial is if I have multiple instances, they should have different IDs. So this is 0, but the next one I drop in should be 1. And it is. And it doesn't matter if I hit play and stop, the second one will always be track current 1, and the first one will always be track current 0. Excellent. So now we will not be unregistering tracks. We can get rid of all this. We can also get rid of that. And we can see this fix me's to see if they still apply. We could be using atomic add when registering. That's still an issue. The plugin instances should register themselves on first load, not only when you hit play. That's exactly what we're doing today. The plugin instances should unregister when you stop so that it is easier to use it live. Exactly. Great. Oh, okay. So coming back to the measurements that we did on Wednesday, Bo is saying that the inputs and outputs may have their own impedances and capacitance, but that's not the wires, as I understood before, not the wires that were bringing the signal in and take the signal out, but the impedance and capacitance of my components. Because my resistor and capacitor were sitting next to one another on the breadboard? Is this what you mean? And you're saying that the interface has an impedance? Oh, so the impedance of the interface may be interacting with the capacitor and forming yet another filter. Oh, okay. And that's an issue because my filter was a passive filter, so it interacts with stuff further down the chain, like the USB interface. That makes sense. If instead of a passive filter I had an active filter or a buffer with an op-amp, that behavior should go away, right? I want to test that next, but yeah, good point. That's why I love streaming on YouTube. You find people who know more than you and are willing to teach you stuff. So yeah, thanks for the input. Do I understand you right? Is this what you mean? The impedance of the interface is interacting with the capacitor, forming another filter, and that's what I was measuring. And an active filter or a buffer would solve the issue. Do I understand you right? Okay, this has nothing to do with the registering situation, so I can skip it. And it's mostly just synchronizing this variable anyway, so I can definitely skip that. Then on the sample block, we compute the RMS of ourselves. Each instance is responsible for computing its own RMS, and that's what we do. But then we are storing this RMS on the global memory. And now I don't want to necessarily just store the RMS, I also want to store the time. So I need to arrange the global memory in a slightly smarter way. I think that the way I'm going to go about this is similar to how we have data structures in our library. And I will do this here on the init block. I think I will do something like gmem track last updated, or just updated at. That will be position 0, and track RMS will be position 1, and in general the track data structure has 2 fields, these 2. And I'm using this as a prefix because it is a data structure in the global memory. I don't know if that's a good idea or not, but that's what I'm going for here. Or maybe I don't need this. I don't need this prefix. This is the data structure. Well, but this variable is going to clash, is it not? It will. So because this name is also used over here, so that name will clash with the variable name over there. I'll keep this prefix until I think of something better to do. So now we have this yeah, anyway, I'm not sure I love the names there, but we have this. So what we are doing is we are saying that our gmem, which is our global namespace, it will have a bunch of addresses like this. And what we are saying is that we are chunking it like this. Where we will have these two fields. They are the updated at and RMS. Updated at will be at position 0 and RMS will be at position 1. And this is a number, an identifier going from 0 and up. And when I multiply by track, and that's the size of this data structure, so far only 2 fields, but I expect that there will be more fields. That's why I'm taking this principled approach to doing this. So this is how you index into the global memory. You first find the place where you want to go. So if I am talking about track 3, for instance, that will be 3 times 2, which is 6, which will give me this point. And then I add the field that I'm interested in. In this case, I am storing RMS there. And I will also need to store the updated at. I will get to this in a moment, but that's the point. I'm going to be writing to these locations in memory, and crucially, this is how I access these specific fields. But I do want to test something real quick, because I am using this strategy of adding offsets to get to the right location in memory. But I think that there may be a better way of writing this, and that's what I want to test out. So let's go to my trusty little test effect where I usually put junk in to see how it behaves. And in this case, I probably want to set an options of gmem so that I am using the liafac test space. And I guess I want to call this test lowercase to follow my convention. Not that it matters. So if I say gmem of 5 is equal to the number 40, can I get there by using 3 plus 2? Of course, yes, the answer is yes. But can I get there using 3 and 2? I don't think so. Yeah, it doesn't even make sense because this is 0. So this is indexing into just the wrong place. This is indexing into not even the global memory. It's indexing into the local memory, and it's indexing at position 2. So it doesn't really make sense. Yeah, I thought that perhaps there was a better way of writing this plus, because essentially when you say something like this, it means go to the address A plus B. It means that you can actually write stuff like this, and this just means go to address A plus 0, which is just another way of writing it. But anyway, I thought that perhaps there would be a better way to write this, because this plus can be kind of cryptic. You are doing pointer arithmetic at that point, and pointer arithmetic is something that is usually hard to grasp. But anyway, I don't think there is a way for me to easily get out of this situation. So let's just continue. Exactly, okay. Your filter interacted with the interface impedance and capacitance. It forms a completely new circuit. Good point, yeah. Yeah, right, and even thinking of all the passive circuits, passive filter circuits, they always have some kind of buffer at the end. That actually makes me think that my idea, I talked about this on the end of Wednesday's stream, I have this idea of using the audio interface as sort of an oscilloscope. If I do that, I have to take care of higher voltages, that's for sure, because the audio interface is not meant to be operated with high voltages. And I'm not even talking about mains voltage. I'm not even talking about really high voltage on the thousands of volts. I'm just talking about like 10 volts. The audio interface is not meant to deal with these kinds of voltages, but I would like to be able to probe these kinds of voltages in my circuits. So I thought of just having a potentiometer to divide that voltage and some diodes to clip higher voltages just to protect everything. So I thought of building this circuit, and there are schematics and articles describing this idea online. I didn't make this up. But I guess that besides a potentiometer to be able to scale down the voltage and the clipping diodes, I think I may also need some sort of buffer. So some sort of op-amp to buffer the output so that I can really measure the circuit. So I guess my oscilloscope probe would be this little circuit with a potentiometer, some clipping diodes, and even some buffers. I guess I would need a buffer before my potentiometer because I want my potentiometer to not interact with whatever I am probing, and I would need another op-amp at the end before going to the audio interface so that my potentiometer and diodes and whatever else I put in that circuit doesn't interact with the audio interface itself. So I guess it would be a buffer in the beginning, the voltage divider, the potentiometer, and the clipping diodes, a buffer at the end, and go to the interface, and that would be my probe for the oscilloscope. Let me take note of this because I think it's necessary. And what do you think, Bo? Do you think that this makes sense? Okay, buffers would do the trick. Awesome. All right, so I need to store the time, and I could just look at time precise, but this is an operation that takes some time. It's not too intensive, but it takes some time to perform, and I'm running this on the sample block. So I guess I can just put this time precise here on the block section, right? And this is something that I went back and forth with, but I think I will have to have some notion of time for one thing or another, so I might as well just have that here. Which actually makes me think that perhaps that whole strategy that we have is okay, this is a tangent, but when we were working on our previous effect using the library, the little widget that draws a waveform, just like this, when we were working on this plugin, we noticed that if the plugin was really big and the CPU was under stress, the timing between stuff would be off. So we would be dropping frames on the user interface and this would be resetting. We saw this as an edge case in weird situations, and I think we left a to-do about this somewhere. But I will leave another to-do here, which is to perhaps change the strategy. And maybe I will leave this to-do up there. Which is to perhaps change the strategy to use this instead of a counter. I'll not get too deep into this, but the way that we detect that the plugin is bypassed on the user interface. So the audio processing is bypassed. We want to detect that on the user interface, and perhaps the plugin is closed, so the user interface isn't showing, but the audio is going through. we would like to detect that too. And the way that we do both the back and forth detection is using these counters, just like this counter. We may want to use just time instead. And I guess the reason why I was avoiding time was so that I wouldn't have to call time precise, but it seems like it's useful everywhere. Or I could just put the time precise over here on the block section, but I think it's something that will be needed for this as well. So that's why I'm putting this on the library. So I will explore this notion. Anyway, that's subject of another coding session. Let's get back to here and use this. And I'm sort of lying because this is not the sample time, this is the block time, but never mind that. It really doesn't make sense for me to be calling time precise on the audio thread over here on the sample section. Okay. So this now stores the time when the RMS was updated. And truth be told, because this is updated on the block section, you might as well put this here. Right? Perhaps I should rename this to be like audio time, because it's the audio thread. And both the block and sample sections are part of the audio thread. I'll leave it to think about this. Moving on. How do we detect the sum of all RMSs? Previously, all the tracks that were registered in the global namespace were active, so we could just loop over. But now we also have to look at the time when they were last updated and take that in account and skip tracks that are not up to date, that haven't been updated recently. So remember, this means that there may be junk in the global memory. As long as you load the plugin once, it will register itself and it will claim that piece of global memory and it will never release it. But that's okay, because we have a lot of memory and we'll just let the memory rot. If you have a very large project, that may be an issue, but I think it would only be an issue if you had thousands of tracks. And even then, you could close and reopen REAPER and all the junk would go away. So it's not the best answer, but it's one answer. I guess you can even close the project, perhaps. I don't know. Anyway, what happens is now we no longer have a simple way of knowing how many tracks there are, because hang on. Isn't there an error here? Don't I need to know the number of tracks that there are? No, I don't. Oh, that's cool. I don't need to know how many tracks there are. I just need to find the tracks that are active. Anyway, so this loop is already looping over all the RMSs that I have collected from all the tracks. All I'm gonna do now is I'm going to skip RMSs that are stale. All right, that would be good. Benjamin is here. Hello, it's great to have you here. And you just watched that 2 times to get caught up. Yeah, I tend to speak slowly and I try to enunciate as best as I can. And I cannot speak fast to save my life because English is my second language. So watching me at 2 times, I think is a good deal. I even thought at some point of having some background music, but I thought that for people watching at 2 times, it could be annoying to listen to a backing track at 2 times. What do you think? Do you think I should have a backing track? Because it does add energy and makes everything more entertaining. but I may pick songs that you don't like, and there is this 2x thing. Let me know, would you like to have a backing track? You can always just play whatever music you want behind my voice, but I think it could be nice, but it could also be annoying, I don't know. Aaron Lanterman is the guy to talk about this. I'm an autodidact when it comes to electronics. So am I. But yeah, the more we talk about this, the more I learn. So I think the backing track would be too distracting. Usually I'm thinking about what you're saying. Yeah, true enough. Sometimes I like music when I am programming, but depending on what I'm doing, it's too distracting. Especially on the streams when I have to really think hard about what I'm doing, because it is usually a tricky problem that I'm trying to solve, like the one today. Only a few lines of code, but it's a tricky problem that we are solving. A problem that Corey himself just left as, where is it? I think there was a question mark. Yeah, is there a better way to determine how many instances are running? That's the problem we are trying to solve, and Corey is a very smart person, and he was struggling to find a better solution, and that's what we are going for. So I cannot have a backing track because I have to think hard. All right, so the sum of our masses is 0. The current track is 0. And this time, well, we do want to loop over all the tracks because this number is the number of tracks that have been registered at all since forever. And they never go away. So this number never decreases, it only increases. But we have to loop over that. And it starts at 0 and adds up. So we really just want to loop over this, not over this plus 1 or something. Looks great. So this is the loop setup. I will not touch that. But then there is this, which is adding. And the issue is that this is adding even old RMSs that are no longer valid. So what we need to do is to check, well, for one thing, this is using the wrong address. It should be using something like this, or better, something like that. But we only want to do that if a certain condition holds, and that is that this track that we are looking at has been updated recently. That means that my current time minus that time, that is how much time has passed since this track was last updated. This is a time precise thing. Well, first of all, this is going to be a number that is at least this much. Or perhaps it may be even smaller if there is some kind of situation where one plugin is running in concurrency with another and the other one has already updated, but that's not an issue. The point is just this number is going to be, for the most part, positive. So let's say that this number is, for instance, the number 5. Of course, it won't be because this is a time precise value, which is a large number. But let's say that this is 5 and this is 3 because the other plugin has been updated 2 units of time ago. So this will be 2. And the more time passes, the larger this number is. This would be 7 and this would be 2. This would be 9 and this would be 2 if the plugin is bypassed. So this gives me the elapsed time, and I want this elapsed time to be small. It is only going to grow over time if the other plugin is bypassed, so I want it to be small. And if it is small, I don't know by how much, then we do that. So this is skipping over the stale tracks that have been bypassed, and this alleviates the need of unregistering tracks because they're just going to be ignored. And crucially, they will be used again if the plugin is unbypassed in the future. Now we need to find a sensible value for this. But the problem is, I don't even remember what is the unit. I think it's microseconds. But anyway, let's see this in action by going to our JSFX test plugin and remove all that and just have some time precise there. Now I can load the plugin here. This is a REPL, right? It's the closest thing I have to a REPL in JSFX. A REPL being a read, eval, print loop where you are like in the terminal where you can interact with stuff. I don't have an easy way to interact with things, but I can always come here and hit Command K, and I can peek into the value of a variable. And it seems like this is given in a large number of seconds, and then there is a lot of numbers after the decimal point with a precision, I guess, of microseconds, but never mind that. Let's just say that we are ignoring stuff that is larger than our RMS window. How about that? Is that a smart move? Well, if the RMS window is too small, that doesn't make sense in the Automixer anyway. But if your RMS window is too small, then you could be running into issues with this. How small would your RMS window have to be? So suppose that you have a 2048 buffer size that's divided by a sensible sampling rate like 48,000. That is 40 milliseconds. That's a very small RMS window. But anyway, it could be an issue, so I will not do that. I will just pick a fixed value and not let this depend on the RMS window. So let's just say that after 200 milliseconds of inactivity, I stop considering that RMS. And this is a sensible value, even with a block size as big as 2048 in a sampling rate of 48,000, because we saw that that was 40 milliseconds. Yeah, that was 40 milliseconds, and this is 200 milliseconds. That's 5 times more than that. So it should be a sensible value. Okay, so the sum of our masses. This check for 0 was only relevant and necessary because we were unregistering plugins. But now we are guaranteed to find at least ourselves because we have just been registered. So we will find at least ourselves in the sum of our RMSs. Oh, but we could have an RMS of 0 because we are silent. The plugin is on the track, but no audio is running through it. So the audio is silent. So this check for 0 still makes sense. Well, but I don't like this conditional because the conditional slows things down and we are on the audio thread, so it matters. And we are doing conditionals here and we are doing loops and whatnot, but let's save it as much as we can. So instead of checking for 0, I can revert to my other strategy of adding an infinitesimal. And that was not holding before because there was some audio coming through and then the division by the infinitesimal was making a huge attenuation. But now the only way you can have a very small sum of RMSs is if there is very little signal coming in, so a large attenuation wouldn't be a problem at all. Yeah, let's add the infinitesimal. And let's make sure that this is never more than 1. So the minimum between 1 and that. So if that is more than 1, we get 1. If that is less than 1, we get that. And the reason why I'm doing this is that this is supposed to be an attenuation. I don't want this to be gain. So even if we have a very small number here, this division will be a very large number, but we are clipping that. There you go. And no conditionals. Now, I don't know if min is faster than a conditional, and all performance work is guesswork, but here is the style I'm gonna follow. Let's see how this works. But I'm afraid it won't work, so I want to procrastinate. Let's see what we have in terms of changes. Let's check the chat, and then we'll test. Okay, I like everything I see. And we will talk to Aaron, hopefully. We are in touch with him. So if you are watching this and you're like, first of all, if you don't know Aaron Lanterman, then go to Lantertronics YouTube channel and learn stuff about electronics there. He is a professor at Georgia Tech, so he knows what he's talking about. And he's a super nice fellow, and Bo is getting in touch with him, so perhaps we will be streaming together at some point. No backing tracks. If you want music, you can always put your own. Fair. Can this be used with Wavelinks VST? By the way, hello, Honest Auntie L. I hope that that's how you pronounce your name. Wavelink VST. Let's see what Wavelink is. It's a software company, and oh, you're probably talking about this. What is that? It's explaining how to set it up, but what is it? Many tutorials. What is it? I don't know. Can I get some images? Is it a microphone? What is Wavelink? Route audio. It is an audio router. It seems to be an audio router, probably capable of loading VSTs, and you are asking, can this be used with Wavelinks VSTs? Well, this version, of course, no, because it is REAPER only, and there are ways to load JSFX in VSTs, but they are not really mature. But the good news is that I am going to be working on, well, actually, I am working on a VST version of this, so there will be VSTs of my Automixer that should work in most DAWs, at least. I will be testing on Logic and Ableton and perhaps others. Now, I cannot speak about a Wavelink because I have never heard of this product, but it will have to be able to do this inter-plugin communication that we are dealing with here. So it may work, it may not work. But the good news part too is that if you're willing to do the routing using REAPER instead of using Wavelink, then you can always do that. And that's what I do, for instance, on this stream. I am taking the audio from my microphone, passing it through a REAPER instance here, and then feeding that into this piece of software called Black Hole. And on Windows, you can use something like Rouge. You can use, I haven't really tested, but I have heard of people using Rouge, using Banana Voice Meter or something. So you can route audio out of REAPER with the Automixer into something else. And I have heard of people who do that. Okay, Benjamin asks, when a plugin is bypassed, it will not update the timestamp and it can be ignored. However, when the plugin is reinserted, will it get a new track ID or will it keep its old one updating timestamp? I believe because I am ignoring this block after the first initialization, I think that it will just keep its old track ID and update the timestamp. That's what I think it will do. But here's what we are going to do. We are going to test this out. Automixer development, edit, and then current. It is 0 right now. Now let's bypass and unbypass and bypass and unbypass and play and stop and bypass and unbypass. Yeah, it keeps its old track ID. So we are wasting a bit of memory because if we delete this and add a new one, its track ID will be 1. Oh, hang on, it's not. That is odd. Is it zeroing out the memory because I eliminated all instances? This is track 1, all right. So if I delete the old one and put a new one, yeah, okay, so when you delete all plugin instances, Reaper cleans up this memory. So there you have it. But anyway, if you keep at least one instance and then keep adding and removing other instances, you are wasting memory and you are making everything slower because the plugins will have to loop through all tracks, even tracks that are ghost. So, and the solution would be to close and reopen the project. But there is your answer. It will not get new track IDs when bypassing. Right now, he's working on a JSFX Automixer. I'm also working on the VST version in C++. For more on that, you can watch our C++ digital signal processing juice study group meetings, for instance, on Wednesday, which is the previous stream on this channel. I was talking about the Automixer, the VST version. And eventually, I'm going to rewrite it in C++ using juice, which will make the VST3 that should work in Wavelength. Okay. It should work. I know of other VST automixers and they don't always work in every host. For instance, I hear that people trying to use some automixer products that I'm not going to name because I forget the names and whatever, but they tried to use it on like Adobe Premiere because they were doing video editing of an interview and it wouldn't work well. I don't know. And it may be like a limitation that is impossible to overcome, because if the plugins cannot talk to one another like this, in this case using gmem, but in our C++ version it would be something like global variables or static class variables. If that's impossible to do, if they don't share the same address space and it's impossible to communicate between instances, I don't think there's a way to implement an Automixer in that context. Anyway. Let's test this and then get on our scooters and get out of here. Well, I loaded the tracks and put some Automixers in there, but let me do that again. So the plan is that now that I implemented all this, first of all, we are getting some audio out and we are not getting loud noises, which is great news. But also I will drop a tone generator, which I removed. I don't know why. And I will drop another Automixer, and we expect to see this bouncing up and down as soon as I drop the Automixer there. So 3, 2, 1, and it is bouncing. We can all celebrate. This strategy works. We don't have to hit play to register the plugins, and I can hit play if necessary. And weirdly enough, it seems to be glitching. I don't know why, and I don't know if it's even my fault. Let me bypass the Automixers. Yeah, okay. It glitches when I start the playback, even if I don't have the Automixer. So it's Reaper, it's not me. Anyway, my new Automixer strategy can register plugins transparently as promised in the title of the stream. I don't have to register on playback, which is the solution to Corey's issue here. Is there a better way to determine how many instances are running? I think so. I think that this way is better. It has some drawbacks, like it's wasting a bit of memory and CPU if you load a lot of plugins and unload many of them, but not all of them, and then you reload some more and blah, blah, blah. But I think that this is very nice. And it works even if you just load the plugin. You don't have to hit play and you have to remember to hit play again when you bypass stuff. Let's test this actually. So if I have my Automixer here, for instance, and I bypass it, this other instance is still running, but it's no longer taking my voice in account. And as soon as I unbypass, it's taking my voice in account again. Oh yeah, thank you both for joining me. I hope that this was entertaining and educational for you. And Benjamin wrote that he left a comment on the C++ study group video from yesterday, but I wonder if that shared memory will work when Reaper plugins run in dedicated processes. That's a great question, and I wanted to answer that, but I didn't have the chance. And I read your comment, and I was like, oh, I should say to Benjamin that there is this whole thing, and then you're saying that you were the person who commented, so I forgot that it was you. Which is a feature that I think is unique to Reaper. True enough, let's see. We have here our Automixer VST version, and this is just a proof of concept where I can load more instances and they know of each other. In a way similar to our global tracks variable, right? They know of each other through a global variable. So the question is, what happens if I don't load the plugin in Reaper, but load the plugin in a separate process that communicates with Reaper? It's possible to do this by right-clicking on a plugin and going to... it's possible to do this before adding a plugin and right-clicking on the plugin and then run as separate process. If I do that, then the Automixer is going to be loaded as a separate process. Let's try that. So run as separate process. And I think that we will even see that it's not loaded into the Reaper window. It's loaded on a separate window. See? It's not the Reaper window. It's a separate window. And I think that there is even, yeah, am I in front of this? No. There is even another process here on the dock. And this is something that comes up when you are running plugins that are Intel on a Mac M1 processor and that sort of thing, or plugins that are buggy may need this kind of bridge. So with the bridge, will the instances see each other? My guess is that yes, they will see each other because they are all loaded into the same separate process. But let's test this. And everything becomes a bit slower when you have this bridge. I'm getting the beach ball now. I think I'm gonna crash Reaper now. Yeah, I'm not getting interactivity here. Let's quit this Reaper instance, and I will have to double check that the stream has not been affected. So hang in tight. It seems like the stream is okay. I'm getting signal out. The bars are moving. My audio is coming through. Yeah, it seems like you can still see me. Let's try again. Let's open a separate Reaper instance. I always run one Reaper instance with my audio processing, as I was explaining about the wavelength situation, and a separate Reaper instance for testing things. So let's try again. Automixer. And does it remember the setting from last time? It does. Okay. And then a new track. I'm not going to just drag and drop. I'm going to add a new one from scratch. And there you go. See, they are on separate processes, but they are on the same separate process. And I guess that even all our plugins that are loaded on the bridge live on the same process on the bridge. I think there is only one process here for the bridge. So all the plugins would share the same namespace, the same global memory, so to speak. Let's do another one. Yep, it works. And let's go to some other settings, because I know that there are other settings. We saw them. Let's go to run as dedicated process and see what happens then. And I guess in this case, there would be a dedicated process per plugin, but not per instance. That's what I think that means. Nope, it's not. Now, oh, see? Now there are different instances, and in that case, they cannot communicate. So if you are doing this kind of setup, the Automixer simply cannot work. And that's what I was talking about before. I think that Adobe Premiere does something like this, or at least used to. I'm not sure this information is up to date, but Adobe Premiere used to do something that amounts to this, having separate processes and they can not see the same address space. There are two ways for the processes to communicate using usual inter-process communication, but it gets really complicated really fast and I will not do it. So perhaps my plugin will not work in every host, but I think most hosts behave like Reaper in the sense that it shares a namespace. Yeah. By the way, great questions, Benjamin. You are making my day here. Native only, prevent bridging. And I think that that's the default. So you think that it will just load in the Reaper window. Yeah. Well, is it? Yeah, it seems so. Can I load this window? Yeah, that proves that it's loaded in the Reaper window. And then naturally, multiple instances will see each other because that's what I was doing to begin with. That was the first test that I did on Wednesday even. And now it's back on default. So there you go. Thank you very much, Benjamin, because these are great, great, great questions. I love it. All right. You have to insert the plugin fresh, still live, perfect. A desirable outcome. Okay, interesting. So if a plugin host runs a plugin in dedicated processes, this method won't work. True. I think that most hosts do what Reaper does. Either bridging or not bridging, doesn't matter. At least all your plugin instances live in the same address space and can communicate using global variables just fine. If worse comes to worse and we really need it, I will do inter-process communication, but it's a pain to do, so I'll try to avoid it. Okay, that answers the question. Thank you, Benjamin, Bo, and Honest Auntie L for being here with me on the chat. Thank you to everyone else who's watching this after the stream, or maybe just lurking around and not being active on the chat. I still appreciate you, and have a great weekend. I see you back here on Monday, and we will continue to work on the Automixer. I just don't know on what yet, but we'll learn together on Monday. See you. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.